Chapter 10, Section 4, number 19, as you can see stated here for the data in exercise 19 of Section 2. So we're building on Section 2. So the things we created back there for problem 19 in Section 2, we're going to build right on that. Since I did that in Excel, I'm going to build right on that in that same Excel sheet that I had before. We'll go there in just a minute. Before that, let's look to see what we need to do. So A, compute the least squares regression line. We'll be using that formula from the text that we were just given. And then we're going to interpret the value of the slope of the least squares regression line in the context of the problem for B. And then for C, we're going to estimate the average concentration of the active ingredient in the blood in men after consuming 1 ounce of the medication. So that's going to be our given, our x value of 1 ounce. We'll substitute the 1 in for our x into our equation to see how that predicts what the y hat is going to be. All right, let's jump back over to Excel since we see where that was. And here is section 411. How about that? So those of you that have been watching, see me recording the videos. I recorded 11 first, and now we're actually on 419. So 419 builds directly onto section 219. Here's that data from section 2. The values that we had are all right here from that problem. And there's the section 219. I have added over here calculations for x bar and y bar, the average value of x and the average value of y. And those are the sum of the x's divided by the total number of samples n. And for x bar and then for y bar, likewise the sum of the y's divided by our n as well. So straightforward into Excel with those. These are all in those same positions. Now that I had it set up for the problem number 11, for those of you that had gone through section 4, problem 11, I copied over the section 19, or that over here into section 19, so I have that same B1 hat or beta 1 hat and beta naught hat equations. Let's look at those briefly here. So the least squares regression line, to come up with our values for that line, we need to have the beta 1 hat and the beta naught. And the beta 1 hat is given by the sum of the square of the xy's divided by the sum of the square of the x's. So sum of the square of the xy's is the blue in the numerator. Sum of the square of the x's is the red in the denominator. Sum of the square xy divided by sum of the square of x's is where that one comes from for the b hat, for our b naught. That's actually going into the equation once we've calculated b1 hat, where we're saying that our b naught is equal to the average y, so y bar minus b1 or beta 1 hat times x bar. And those values were the values right here that we have. So we have our y bar is the blue that's in cell G8 minus the quantity, our b1 hat, so the beta 1 hat, the value we just calculated above, so that's the red times the purple, which is in, so our cell D26 times our cell G7. So do that and multiply those and subtract that from G8. That'll give us our value of beta 1 hat. So then I took these and I reduced the number of significant digits down to just 3. So if we were going to look at this one like we did before, so our y hat is going to equal our 0.043 times x plus 0.001. So there would be our least squares regression line. All right, since I've got that in our head now, we can continue on to B. So B was interpret the value of the slope. So in this case, the value of the slope is given every ounce additional consumed by the demand in the, this is for men in this example, of the medication. So for every additional ounce consumed, the percentage points go up 0.043, which is 4.3% for each ounce consumed to be the amount in the blood after 30 minutes. So that's what's happening there. So for C, it said estimate the amount in the blood after 30 minutes if 1 ounce is consumed. So again, we're going to put that value into our line that we just had, that least squares regression line that we had calculated. So that was y hat equals, in Excel terms up here, we've got it in Excel terms of D26 times x plus D27. In terms of our least square regression line, our y hat equals our b1 hat times x plus our b0 hat, or the red cell as shown here. So we're going to have 1 for the ounce consumed put in for our value of x. So in Excel terms, we have our cell there in blue, our B1 hat, which is in cell D26 times 1, plus our B0 hat, which is in cell D27 in red. And when we go through and calculate that out, we wind up with 0.043, which makes sense since, well, actually it's out there. That doesn't make sense, does it? Because I have 0.043 times 1 plus 0.001. Well, if we go out into our significant digits, out into the 0.043 and add to it 0.001, and we look at those significant digits out there into, say, look, we had even further. Let's do it this way in Excel. See, we had even more out there in Excel. And as we add those together, when we add it, it still rounds off to 0.043. So adding significant digits is where we lose that point of things don't look like they're adding up like I thought they were going to. Because at first glance it'd be 0.044. However, with those significant digits, it rounds down that way. Okay, there we have it. Question number 19 in section 4.